Hi there, welcome to this short video on the initial steps in cable sizing calculations. We have a circuit here. It's a 3 kilowatt load connected to a 20 meter run of cable. Cable itself is a flat twin and earth or two core and earth thermoplastic sheathed cable, clipped direct to the surface. At the origin of the supply, we have a BS3036 fuse board. Okay. Other key relevant pieces of information: as the cable's installed, as it moves through into the attic, it goes through 400 millimeters of glass wool as it's entering the attic, totally surrounded. And in general, the ambient temperature in the location reaches a maximum of 30 degrees C ambient temperature. Okay, so our initial steps, taking that 3 kilowatt load, is to calculate the design current, IB. So how do we calculate design current? Well, we take the power, that 3 kilowatts, and divide it by the expected volts. That's 230 volts. That's the volts declared U0 by the distributor. Okay. So 3000 watts divided by 230 volts gives us 13.04 amperes. Beyond that design current calculation, we then need to select our overcurrent protective device, IN. You'll see there I've identified it as 15 amperes. That's because BS3036, the next fuse size up from that 13.04 amperes, is a 15 amp device. So a BS3036 fuse, that's a semi-enclosed fuse. Okay, that's about a fuse wire in the fuse carrier. Okay. Beyond that, we then have to calculate this clipped direct flat twin and earth cable's minimum current carrying capacity, IZ. So how do we calculate IZ? Well, we take the nominal value of the overcurrent protective device and we divide it by correction factors that we find in Appendix 4, Section 3. Okay. So what correction factors do we have to look into? We need to look at correction factors for ambient temperature, correction factors for fusing if it's applicable, correction factors for grouping, and correction factors for thermal insulation. Seeing as how this is a cable installed within the installation. We've not got any buried cable, so we don't need to take into account any of those correction factors. Okay. So first correction factor we're going to look into table 4B1 in Appendix 4 in your BS 7671. And we're looking at the correction factors for thermoplastic cable for an ambient temperature of 30 degrees C. That's at correction factor CA. So we go down the 70 degrees C thermoplastic column and plot across from the 30 degrees C, and you'll see that the correction factor there is 1. In fact, if you look at the heading for this table, it tells you that the temperature that we're using as our base is 30 degrees C. Okay, so we have that 1 as our correction factor. Other correction factors we need to think about grouping. Well, you could see our cable, it was installed and it was only clipped itself. There was no information, other information given about it being clipped with other circuits. So we've got cable single layer on a wall, and you'll see there for one cable or one multi-core, one circuit or one multi-core cable, we have a correction factor again of 1. That's at reference method C. Okay, again, if you look in the heading, you'll see there that it's talking about 1 or more cables. So our reference here is 1, just like the ambient temperature reference in the previous one was 30 degrees C. So the correction factors here are 1. Other correction factors we need to think about is thermal insulation. If you go back into section 2.6 in Appendix 3, Appendix 4, you'll see the correction factors for thermal insulation. So underneath the paragraph there, you'll see this table. Our got in the wrong part. Our correction factor for the installed method is 0.51. That's for that 400 millimeters of completely surrounded our cable completely surrounded by thermal insulation. So a correction factor of 0.51, that's from 2.6 in Appendix 4. Then we need to find this correction factor for fuses. If we look at the symbols and at the end of part 2, you'll see there are rating factors for semi-enclosed fuse to BS3036. It says go and look at Appendix 4, Section 3. Now, Appendix 4, Section 3, that just gives us the list of correction factors and currents. Okay. When you look in Appendix 4, Section 4, however, in the third paragraph down, you'll see where BS3036 fuse been identified, and it's telling us we have a correction factor, a rating factor of 0.725. If you were to go and look at overcurrent protective devices in your index, your fuses, if you go and look at semi-enclosed fuses, if you look at overload protection by, that takes us to regulation 4331202. And in 4331202, you'll see there we have a rating factor of 0.725 again. Okay, so that's our correction factor, correction factor for the semi-enclosed fuse. It's the only fuse with a correction factor. So looking back here, we can now take a list of our correction factors. Our 1 for our ambient temperature, our 0.725, our 1 for grouping, and our 0.51 for thermal insulation. Now this correction factor for ambient temperature and this correction factor for grouping can be disregarded because the correction factor is 1. Okay. So the only two that we are interested in here is the correction factor for our BS3036 fuse and the correction factor for the thermal insulation. Okay. So our next step, as I said, is to calculate that minimum current carrying capacity of the cable, IZ. So we take the nominal value of the fuse and we divide it by the two applicable correction factors, CF times CI. So that gives us 15 amperes divided by 0.725 times 0.51. So that gives us a current value of 40.57 amperes. So as I said there, that there is the minimum current carrying capacity of the cable because of the installation method. Okay, because of this overcurrent protective device, this flat twin and earth clip direct going through glass wool in a general location that sits roughly at 30 degrees C with a 3 kilowatt load connected on the end of it. Okay, so now that we've identified that minimum current carrying capacity, we need to go and identify a cable that can handle at least 40.57 amperes. Okay, so that's its tabulated value IT. Now this cable is a flat twin and earth. We find the tabulated values for flat twin and earth in table 4D5 and appendix 4. This is table 4D5 and appendix 4. Our reference method, as you can see there, is reference method C for the cables clip direct. And as we run down that column 8, you'll see there the first current value that we have more than that 40.57 is 47 amperes. And if you plot that across, you'll see there that the minimum cable size, because of our installation method, is a 6 millimeter squared conductor. Okay, so it's a 6 millimeter squared conductor is required. So hopefully that helps you with the initial steps of cable sizing. Remember, you've got examples in your folder. If you run into any difficulty, you know how to get in contact with me. Although you won't be expected to carry out this entire calculation in, for example, a Sitting Girls 2382 exam, you may be asked to identify correction factors, you may be asked to carry out part of the calculation or identify fuse ratings, for example. Any point of that cable size calculation or initial cable sizing calculation could be asked in your Sitting Girls 2382 exam.